think let's make a start since we have a few minutes in. So really, good afternoon everybody. So thanks for coming to this session that we have here on the future of food, 3D printing and personalized nutrition. So my name is Choy, so I'm assistant professor with SUTD. I belong to the Science, Math and Technology cluster. So very privileged to be able to share with you some of the work that we do in SUTD. And today we have Choy here, who is chairing or leading this program on SkillsFuture on human health potential. And we also have a researcher in our team, Shi, who will be later sharing some of the demo on the flip printing itself. So I hope everybody have a good lunch. So I must apologize for this session today. We are not going to give you a lunch food printing. So we're just going to showcase what this technology can do, particularly for future, and showing you some of the work that we do and what are some of the potential application of this 3D food printing. So I think one of the questions that you may have in your mind is, what is 3D food printing, right? So 3D food printing is also known as layering manufacturing of food, which is digitally controlled robotic construction process that can build up complex 3D food products layer by layer. So you can see this picture over here. So this is your printer nozzle containing your food products, or we call it food ink. And you'll be just layering, and constructing and manufacturing the food that you have the intention to print. And with this technology, we think that food can be designed, fabricated to meet individual needs on health, condition, and physical activities. And by printing really the exact amount of food that can deliver the exact nutrition content that we can give it to various people of different needs, which I will share in great detail in my presentation later. So why 3D food printing? And we think that by doing 3D food printing, it can really has a few different advantages. So one advantages that we are thinking of is it can give a customization of the design. It can also personalize nutrition for special needs. Food sustainability, as you know, due to COVID and supply chains get locked down. Singapore, where we import food 90% from external sources, so we are challenging, right? Because we do not have enough food. So the government is also thinking about food sustainability. That's why they come up with this goal of 30 by 30, right? By the year 2030, we must be able to produce 30% of our food needs within Singapore. And also, we think that this may also help reduce food wastage and potentially also help to upcycle food. And we think that 3D food printing may address some of these needs that we are facing in today's world. So how does 3D food printing works? So the current 3D food printing starts with the design of the food that you want to print. And there is software out there that can really help to design the food that you want to print so that it can be finally printed layer by layer using this food printer, which we have one over here and one in the booth. And by creating the design itself, you can upload it to the printer that generates a code, and then you can start the printing process that you can see here, where you first design it using 3D software, you extract the file, you reconstruct it using the software, then you get a code, and then you can upload to the printer and you can print out the food that you need, which is a 3D printed object. So as you can think, the food itself is a 3D object that is able to hold its shape. So one of the key factors that allows it to be able to hold its shape will be the properties of the food itself. So then that comes to some criteria that we need the food in to have in terms of its material properties. So one factor will be it must be self-supporting, right? It must be able to maintain its structure. So after printing, you don't want the whole thing to collapse. So that's the thing, right? So how does the food, after printed, can hold its shape? So that is the most critical part of the printing that we want to achieve. Otherwise, you print out that everything will just collapse. Then that you will not achieve what you want to achieve. So it depends on the rheological properties, viscosity, flowability, and also as a bit shear thinning behavior. So these are quite technical terms, but basically the idea that I just tell you is whatever you do, right, when it prints finish, it must be able to hold the shape. And it must, if you are thinking about post-processing it, so if you print the food that is raw, it must be able to maintain its shape after printing that. If you are doing cooking or baking after that, it must also still maintain its shape. So that's what we mean by resist post-processing processes such as baking and cooking. So we must achieve all these in our mind so that when you serve the food out to your friends or even if you are doing business, serve your food out to your customer, it must still maintain the shape that you have in mind and able to deliver all these visual effect, taste good and everything like that. So this is what we are trying to hope to have for the future of food. So having know the importance of your food materials itself. So when we think about the food materials, you can think of it as ink, right? So if you think about any normal printer you use to print out your documents, so you have the ink, right? So in this case of food printing, what we call is food ink. And you can you can print a few different types of food ingredients or food materials. And we classify them into 4 different categories. So you have certain foods that by nature, based on the food properties of the food, is able to just print by itself. So we call this natively printable food materials. So some of these food that you know that belongs to this material is like chocolate, milk, dough, for example, cheese. So these all belongs to printable food materials inherently, right? So I will be sharing some examples using chocolate and milk. And we have something called non-printable traditional materials, which is your fruits, vegetable, meat, and rice. So by default, what does we mean by non-printable traditional materials is just normal food, but they cannot be printed normally. So we must do some formulation of the food ink to be allowed to print that you see over here, right? So we must add something to make it hold its shape. Then we also toy the idea with alternative ingredients. As you know, some of the media out there, we are talking about alternative proteins, whether it's plant-based meat, insect proteins, cell-cultured meat. So we also toy the idea of using 3D printing using alternative ingredients. And lastly, we also, to aid with sustainability and reducing food waste, so we also try to do food that is discarded, such as your food byproducts, such as okara. So when you do or drink or make the soybean, right? So the waste that comes out of soybean is okara, and we can do 3D printing on that, and also orange peel that, you know, when you Chinese New Year, you all eat the Mandarin orange, all the peel throw away. So all this can be recycled, upcycled using 3D food printing. Yeah, we are trying to achieve over here. So I'll give you a few examples of each different class of food ink. So you can see that chocolate and milk belongs to the class that can be printed natively. So the material or the properties of chocolate itself fits very well with the food printer and can just print by default. And you can see some examples. So for chocolate printing, as you know, chocolate is when it gets too hot, it will melt, right? And when it's cold or hit a certain temperature, it will become solid. So for chocolate printing, we are using hot melt extrusion. So first we have to melt the chocolate into liquid. Then when you print, after printing and you hit the right temperature, it will solidify based on the shape that you want to print. So with chocolate printing, you can see that we are able to achieve a few different shapes that you can think of. So you, as mentioned, all these shape and design is pre-designed and coded with software that you can fit into the printer and you can just print out any shape that you are thinking of or up to your creativity. And the other product that we can think of printing is milk products. So milk is slightly different. So for milk, we use a technique called cold extrusion. And because this, depending on the rheology properties of the milk, where it is able to print out cold. And again, you can see the researcher who do this is able to print this creature. So anyone can guess what we're trying to print here? Any idea? If you watch Star Wars, yeah, Yoda. So this researcher maybe he's a big fan of Yoda, right? Doing the fighting, so he's able to recreate Yoda using 3D printing of milk products, right? And the advantage of doing 3D printing is we can actually mix multi-materials together. So later when you come and see a printer, there's a few nozzles in there, and each nozzle can be a different type of food product. And you can actually design and create different mixture of ingredients to print your structure, right? So in this case, we are using milk and chocolate, which kind of usually you'll see in the market, right? These are very good combination as food. And we can actually print like a sofa using different layering of milk and chocolate. We can also hide the milk inside we can hide the chocolate inside the milk. So you can see in this case, the exterior surface is milk, and we can print the chocolate inside. So that when somebody thinks that it's only a milk, when they take a bite, then the chocolate starts coming out. You get surprised. Or you can cover it up, and then over here we toy the idea of mixing 4 different ingredients. So you can have a mixture of ingredients if the properties kind of can be able to work together. Okay, so what I shared earlier is really about food customization. So this is more like selling or designing food for commercial purposes maybe, but we also think that 3D food printing has bigger costs. It's able to help personalize nutrition for special needs. And one of the examples that we'll be using is for elderly care, more for specifically for dysphagia patients. So dysphagia patient means those people have some swallowing disorder, and we can use 3D food printing to really help them to eat and also eat with dignity, as the dietitian put it. And we also think that 3D food printing is able to help with food sustainability and also reduction of food waste and food upcycling, which I will share more examples in the later slides. So as you know, Singapore is an aging nation, so as we progress into the future, more and more people get older, and once we get older, right, we really need to think about how to take care of our elderly. Our generation before us have really contributed to our nation building, and we hope that we are able to develop technology to really take care of them. And one of the problems where this elderly patient face is chewing or swallowing difficulty, which may be associated with either stroke, dementia, and things like that. So they cannot eat properly, right? And when they go to the elderly care home, they are served with this pureed food. So we kind of blend up and mash up the food to the right texture because they have swallowing disorder. So we are really serving our elderly in the aged home this type of food. And this type of food really doesn't look very good. And sometimes if they don't see nice food being served, right, they don't feel like eating, so then they become malnourished, and then they are sick, then they really doesn't help with their healthcare. So we are thinking of using 3D food printing to really create food that tastes nice but also looks good, so that they can feel like eating when they see the food being served to them. So that brings me to the kind of second class of food category, which I mentioned before. So the non-printed traditional materials. So these are food that we usually eat day to day, right? Your rice, meat, fruit, vegetable that we eat day to day. And because they cannot be printed natively, just like chocolate or milk, we need to do some processing to the food materials. And what are the processing we're going to do is the addition of food additive called hydrocolloids. So hydrocolloids are added to the food so that the food are able to be extruded during the printing process. So one example is that we have done is to print fruit mainly vegetable. So and because fruit and vegetable has high water content, so when you have high water content, imagine you put it inside the cartridge to be printed, then it will just flow up and it will just be a mess anyway. So we must, it has a difficulty holding its shape. So we must, to increase the printing outcome, we must add food grade or food approved materials or additives such as hydrocolloids. So you can see a few examples I use here: xanthan gum, kappa, Canadian locust, bean gum. So all these are like a bit like gelatin, like, you solidify the food. And when we formulate the food in, you can also potentially add other flavoring supplements or even other items that can improve the nutrition. So by doing so, we can modify the product food to make it look nice and taste good and meet the nutritional need for the dysphagia patient that is safe to eat, and hopefully we can really develop this technology good enough that can be adopted in our hospitals and nursing homes so that our elderly is well taken care of. So this is kind of how we do it. So we prepare fruits and vegetables. So one example is carrot, which you see example over here. So we boil and steam and grind the carrot. We add the hydrocolloids. Then we go for printing, and then we can see that we can able to print out the 3D construct of the vegetable itself, and then we subject them to a few different so-called experiments to make sure that it fulfills all the right texture, right rheology, and more importantly, it fits into the International Dysphagia Diet Standardization Initiative, which is the EASY test. So this standard is really used to classify food for dysphagia, so that when we serve this 3D printed food, they met the standard to be fed to the right patient with dysphagia. So you can see we have done a few experiments. So we already have created the formulation. So the key here is the formulation of the ink to be printed for garden peas, carrots, and bok choy. So you can see that if we have so depending on the food or vegetable that we print, the formulation is different. So we have to experiment with different ink formulation, and you can see that bok choy, which is very watery. So you can see when you print, it will just collapse. So we are trying to achieve different formulation of additives so that we can print out the product that is able to hold its shape and also texture. So you can see that we have ink 1, which is having the right formulation for garden pea, and this ink 2 is the right combination for carrot, and ink 4, which is the best out of the 5 for bok choy. And you can see some of the failed ones is just because we didn't have the right combination to make sure the carrot holds its shape. And after printing, we have to make sure, if you ever want to serve this type of food in hospital, nursing home, elderly care, you must be able to meet the standard test, right? So we do a fork pressure test and a spoon tilt test, and we can see that by doing this test, we're able to meet the international standard for dysphagia. So we are looking at the purely food over here for to serve the dysphagia patient. So a short video on how this is done. So basically, you just use a spoon to test the texture of the food. Make sure it's not hard. If it's too hard, the people with swallowing difficulty cannot eat. So we are making sure that while we're adding everything to make it solidified, it's still able to meet the standard for a dysphagia patient. So in the end, we hope to really serve this kind of dish in a nursing home using 3D food printing, and you can see we can create many different types of shapes and forms using 3D food printing, and able to serve this type of visually pleasing food in the nursing home, right? So we have garden pea, carrot, and bok choy, where we can optimize the print with the addition of one or more hydrocolloids to make sure that the vegetable itself is able to hold its shape. And over the series of hard work of many researchers in our team, we can see that we have a library of food in formulation, which consists of cauliflower, sweet potato, sweet corn, beetroot, pumpkin, yam. We also done fish, so pollock and Hollywood is fish. I've shown you chocolate and milk, and also carrot before. So you can do and work with multiple food materials. That's the thing. And each formulation of the ink itself is quite unique because the inherent properties of the food materials is different. So we have to mix and try and error with different combination of formulation. So the next remaining part is more on food sustainability, and is more like the future of food, where we are playing 3D food printing with alternative proteins. So you will see in the news more recently that we are trying to develop technology to grow meat in the lab. So this is the recent news of cell cultured meat, and Singapore is the first country that approved the use of cultured meat for chicken. I think chicken meat is being approved, and they're building a lot of facilities to really upscale that so that it can meet our demand for chicken, especially our neighboring country don't sell chicken to us, and we can still have chicken to eat in the future. So you can see that there's many different generations of protein needs. For animal-based, which we already know, your pork, beef, lamb, plant-based for vegetarian, and insect, microbials, and lab-grown meat. And we're trying to see whether can we combine 3D food printing technology with the lab-grown or some of the alternative proteins. So a lot of the lab-grown meat currently is more like meats. So we are growing a piece of meat, right, that is mashed up like minced meat. So we think that with 3D food printing, we can actually try to mix ingredients and hopefully able to print a steak, right, that you can consist of muscle and fat and so on and so forth when we mix the ingredients to print. So this is what we're trying to achieve over here at SUTD. And one of the examples that I will show you is using alternative protein, and we are playing with insect proteins. So one day I serve you crickets, right, bugs like this, may be very disgusting. You may not want to eat them. But how about if we process them and make it into a material, food in material, and then we 3D print it into something else, look like chicken, maybe you will likely to accept, right? So we are still doing a lot of research in this area. So we are just going to share with you why we are considering insect proteins. So insect protein, strange enough, has very high protein content, right? So this is cricket that is grown and farmed in the lab in Thailand or somewhere, and then they mail it into flour, and then you can see, right, it's very low calories and very high in protein. And in fact, how much protein is in the cricket is actually more than your sirloin steak, more than your chicken breast, more than eggs, and more than salmon. So it's a very high protein insect, right, or animal. Yeah. So you can see that there is a lot of, and the resources taken to farm or grow crickets takes much less than a cow, right? So if you think of the input resources to grow them and the output in terms of protein, you actually is very in the favor of growing cricket to be for human consumption. So what we did in a lab where we are trying to use 3D food printing to really get rid of the visual effect of the insect itself and try to bring it into something nice. And we can see that we have tested black soldier fly larva, cricket, and your other standard soy protein. This is silkworm, weed, and spirulina. And we try to mix them with carrot powder, and we can see what is the combination of formulation needed to really create the print. So visually what we are doing is, earlier I showed you we can print carrot, and we can fortify this vegetable with protein from insects. And you can see that we have used black soldier fly larva, cricket, and silkworm. And we kind of transform how they normally look like into something else. right, that can be potentially fortify the original carrot with high protein content, and then hopefully we think that this may be more acceptable for the general public through the use of 3D food printing. And the last part of my presentation is really focused on the food sustainability, that we can actually upcycle food waste and use some of the byproducts of the food that is thrown up, so that we can repurpose them and bring back into the food chain. So some of the common foods that people throw out after consumption is like orange peel and jackfruit. We usually eat the fruit, but the seeds usually can be also eaten. So I think when I was young, my parents used to keep these seeds, boil them, and they peel open and taste like chestnut, right? So then this can be, if people don't like to eat seeds or they are scared of eating seeds, then we can actually use this as food materials, put through our 3D printer, and we can create different type of food products. And soybean, right? Soybean is, we drink the soybean, then the leftover product is okara, and we can actually use those materials, 3D print, and bring that into the food chain. So I'm going to just show you a few examples. So this is 3D printed of okara, so you can actually see that we can create nice shape and structures using this wasted or thrown up material. And similarly with orange peel waste, so we collect a lot of orange peel, formulate them into food in your lab, and then we can use it to create multiple shapes, design that is up to your creativity. So just the last few slides before we start the demo, so we can see that 3D food printing, what we're going to do next is really go and try to work out the texture design. And we're also thinking about personalized food in terms of hospital. We already done some work there, and probably the next market segment that will target is soldiers and sportsmen, where some of their training may require more high protein and things, so that we can customize food that is required by these people who are physically active and require a lot of nutrients. In the area of sustainability, we are looking at alternative proteins, insects, waste, and at the end of the day, we are hoping through our work, we create this library of formulation of food in that we can really use this knowledge to really build what we call digital gastronomy, where we can just click one button and we can print food that we want to eat that looks nice and tastes good. And we also recently launched a book that is our Minister of Health, Mr. Ong Kang, also carries it forward, and we hope to launch this book in August. And last but not least, thank you very much for your time to join us today. So on behalf of the Digital Gastronomy team at SUTD, we thank you for your presence. And we will welcome any questions on some of the work that we do. And later, I think Sir can definitely do a short demo on how we can print some of the food that I shared with you earlier. So once again, thank you very much for your time this afternoon and coming to SUTD for this event. Thank you very much.
Okay, thank you, Choy. Do we maybe Shen will perhaps set up the food printer, and we have time for a few questions for Dr. Yeo Choy right now. How you're looking forward to eating crickets and silkworms? Yeah. Otherwise, if you want to leave your questions to later, it's fine as well. Shen, do you need to warm up the printer, or you're good to go?
Yeah, it's printing now.
It's
It will take
printing
about
already.
1 to 2 minutes to calibrate it.
Okay, so
Yeah.
in the meantime, I'll probably walk around with this sample first.
How much does it cost to print?
How much does it cost to print?
Yes.
So currently, we are still at the research and development phase. So I mean, the main cost will be having the hardware itself, which is the printer.
How much is this printer first? So you need
This one is off the shelf, $5,000.
$5,000.
$5,000.
Off the shelf.
Yeah, and I think we also Yeah, so currently now we are using commercial printer, but we also have plans to do our own in-house printer to make sure it's more customized to our research direction.
So as in if let's say per item I want to print, there won't be any. How much will it cost if let's say I want to print the item?
The item itself really depends on what food material you do. I mean what food material you buy. So that will be really the cost. Because if you really to count from a business perspective, right, then you will need to count all your manpower and everything. So but it will be exactly how you will have prepared the food and then make use of the printer to achieve that. In terms of the food preparation.
Roughly how much will it cost? If let's say I want to print the one that you're printing right now.
Yeah.
Right now it will be potato, so it will be cost of maybe one potato.
Only the cost of the potato, the ingredient only?
Yeah.
And maybe the time to prepare the ink.
Okay.
Yeah.
Then what about the software?
The software is not a running cost. I mean at the start it comes with this commercial printer comes with the software.
Okay. Then if let's say I want to make specialized customized design,
That will be up to you to design the design first. And then it's like
just input inside.
it's like like you draw things on like maybe what's that? Graphics software, and then you later print it out. It's similar to food printer where you create the design.
Okay, come closer to the okay.
Then you
I
print
think we
it
are
out.
very small group. So
Yes,
just
yes.
come closer.
So it's like a one-time off thing that you create the design, then you can keep printing the same design.
So that you're printing a star, yeah?
Yes.
And this is default print in the printer, is it?
Yeah, one more will be.
Okay, come. Maybe you all can walk past the printer so that people behind you can take a look. Okay. So this is the Foodini, right?
Yes.
Yeah, the brand. This is a commercial food printer. So we recently had a competition, a food printing competition, where we invited students in JC and Poly to form teams, and then we partnered them with trainee chefs from Sunrise Academy, and they were challenged to 3D print dishes using yam. So the first round was yam was the product, and then we selected 6 finalists, and they came back and they had to use food waste, right? So usually discarded parts of food to print their final food dish. Yeah. So that was recently concluded, right?
Yeah, I think quite recent, few weeks ago, and CNA come and film.
Yeah, I saw that on TV.
Yeah, so, yeah. And but so our end is we are engineers, so we really look after technology, but we are not chefs by training. So the idea is we want to give it to be tasted, then we want it to taste good. That's why we thought of the idea to partner a training chef from Sunrise Academy that really the chef will be in charge of the flavoring. Then some of the students will be learning how the technology works. Then you can actually combine the best of both worlds and print something that looks good and tastes nice.
So this is the nozzle. Yeah, so you would load the food into these nozzles, and you see that there are 5 different slots, right? So you can print multi-materials. Yeah. Okay, so this is what we printed. It's a star. So you can see the pattern that was.
But how do public challenge prospecting?
Oh, it's over already. This for this year.
How
So
publishing how they spectate?
was it open to the public to come and view? No, right?
Open the public for what?
To come and view the
Support.
competition.
Oh, the competition is closed door.
Yeah.
So it's really more like an exercise.
I thought public can just drop by to spectate, support?
I'm not sure if there's an open invite, but the participants are actually from secondary school and poly, so it's more like student-driven, student-targeted.
So yeah, you see that this commercial printer itself
How the
has
public join?
pre-ordered.
So the competition is organized for students. Yeah.
Do you have any preference? What shall we do? Sure. Okay. Chef, that sounds good.
Sorry. Is it then why cannot open to public?
So I don't know whether they actually advertise it open to public, but the selection of
So currently we are in the process of developing
targeted.
new CET courses, so not yet. But right now we are just trying to showcase some of the up
Yeah,
and
that one
coming
I'm
kind
not
of
sure. I'm not sure because
work
they
that
are.
we're doing.
I don't know how they have done it.
So again,
because I
it's
work
kind of
with food, so I
redesigning food,
do
rethinking gastronomy.
they allow public
Some
spectate?
of our researchers are very interested.
So it's more at the research.
More at the research level.
Less so at the undergraduate.
The undergraduates all have 3D printing.
I don't think so. That's why
So they know
I
how
don't think so.
you know,
Because
create
it
a
was
like a CAD design, they know how to use the 3D.
event where they invite.
But whether or not they're doing digital
Why cannot
design,
even publish
Maybe I don't know. Honestly, I do not know why how it is done.
Which year was it first started?
This year, this is the first year.
Then why they never open to public in the first place? Why cannot call it?
Yeah, I suspect
so
is
there
the
are animations, they will do new projects which are undergraduate research
to make sure it's
so they
done
will just
safely
contact
lah.
the course say,
Yeah, because of
so I want to
pandemic, we
can
don't want too many
can I
people to come.
do a
So
project
I'm not
with
sure.
you? So usually
So it's under
Maybe hopefully next year.
Who's the organizer?
Yeah,
All the
next year maybe
students
we'll
access
Who's the
to
organizer?
3D printers.
the school lah. SUTD is there.
I know it's who's the staff in class.
Huh?
Who's the
so
staff
actually
in
every
class?
of our fresh
staff
first year student classroom there
The
was
staff in charge, Professor Choy.
not food 3D
Is he
but a
around?
regular 3D so
You
the
can
students
contact him lah. He's
can
today
play
is
around
not
with 3D
here.
printing as soon as they come into SUTD. Actually Sean was an undergraduate with us.
Okay, now you're a research student.
Oh, so it's scaling, is it? It's like
It's sort of
it's just
calibrating.
it's extruding a
We
release.
were actually to raise cut first
Oh,
to
interesting.
sort of get a feel of it before starting to actually print.
So you prepared the ink separately, like you could do the meshing, boiling.
Something like hot glue gun we're working on. So what do you major in? Robotics. Robotics.
But as part of engineering or
It's under
yeah. It's one of the tracks under
interesting. So do you share your interest on 3D for printing? Where you from? No, they're asking in general. Yeah. My son is licensed now. On intensive stuff. Because nowadays, even as parents for children to go to the uni, there's quite a lot of options.
Yes. Yes. So I think one unique thing about SUTD is really super hands-on. So if your son enjoys learning by doing,
Yeah.
really doing projects,
But still not familiar the difference between some of these engineering product design versus sustainable design. So asking.
Different pillars lah.
Yeah, yeah. I work in university also. I work in SIT. Yeah, but it's a bit different. Yes.
so these are this is 2 layers.
Yeah.
So if you wanted, we can build up. Okay.
And the other thing that determines the print time is the nozzle head. So this is a 4 mm nozzle, it's quite thick. I could have used a 1.5 mm, however, there's a risk of jamming. So if the ink has some debris in general holding. Yeah.
Now, do you have any more questions? Maybe they take any questions you have. Or should we go nearer? Good. Touch the food if you wish.
Oh, that's okay.
Industry 4.0, which is stuff like this. And computer engineering. So you see that they may end up in employers that traditionally hire these types of students. But I think the difference is that our students, although they specialize in track, they actually have a very broad engineering background. So they all have some manufacturing experience, they all have some electronics background, and they all have some programming background. So I think they can move on. Versus if you mechanical, then you do very little coding. Yeah. So I think in terms of working, the feedback is good. Students are really good at you give them a partner, they can get started immediately because they already have all the pieces that they need, and they have practice with the design project. Versus if you have a more traditional engineering, then they say, I need to meet up with the people first.
So every time
repair mechanical
I
engineering.
finish painting, yeah, I change the location.
So our students can integrate. So I think that's different.
So,
But
but if
of
like
course,
maybe in the
because of that, we can't go as deep as a traditional engineer. So what our students do is after their 4 years here, they realize, oh, actually I love orthodontics. So maybe they do a master's to really get that area, but at least they have the general concept now. They understand how to right? Because they have reverse engineering courses, so at least they know
Skill up.
manage their
I want to change something. Find that I need to change that to prepare the supply and again.
Singapore, what's the question?
We have, let's say, 450 students each year
These are all
for, because our first year is formal, and then we group them in smaller cohorts of about 45 to 50 students.
So
So
let's
when
say
you come in,
so
they
the cost
already
of
have
everything will be the
friends like 40,
and whatever I'm
45
using
other friends.
ingredient inside the
So to
contract, right?
create
Is there any
small,
maintenance?
small group learning, more interaction with instructors. So that is the first year of learning. So many of our students, even when they graduate, they still are very close to the classmates from their first year. So it's a very, you're not kind of left on your own kind of environment, but you build when you eventually start. And I think it carries on to particular years where I see competition. You know, people don't like fight for grades, like, oh, I took an A, otherwise, but in fact, it helps. So I think this is, so another thing that I find very unique about it is it's not a cutthroat environment, it's a really family, everyone's helping each other out.
But you almost trimester system. That's why it's like.
Actually, we've always been.
Always been.
Always been.
So actually that cuts your own break. You don't have to translate their own exchange.
They do factor it into our so term 1 and 2, and then between 2 and 3 we have a break of 1 term. Then 4, 5,
So
between 5 and 6
just
is
the
another
cost
break.
of
Then 6, break 7, 6, break 7, 8. Yeah, so they actually have 3 breaks.
Thanks for your thank you.
Yeah. So we've changed our curriculum in the last, from the last year. Yeah. So now we
Thank you so much.
structured in these 3 breaks into the curriculum. And we begin in the fall and we end in the spring. Before it was a bit different. We started in May and then we ended in September, August, September. So it's a bit different. So now we're back to like everybody else. Start in September, end in May. Yeah. So you can take a look at the website for more info on what it is.
Thank
How
you.
was your son?
My son, year 5, ACS high year.
Oh, okay.
One more year lah. I
Okay.
think some of his classmates participated in this.
Oh yeah,
Some
the-
schoolmates.
Yeah, I think the
Schools
targeted
send a
schools
team,
lah,
yeah.
schools and poly. Yeah.
Mm.
So just unique.
Mm.
Find your programs are quite interesting.
Yeah, keep an eye out for some
Open
of the
day-
other
open day can come.
opportunities.
Still early lah, one more year. But they
Yeah,
are already
but just
talking
come.
about career planning and the school prepares the children. The boys quite early.
Just come for fun lah. I mean, open house is a showcase of
Yeah.
who we are, what we do. So
Correct,
you can just
correct.
take a look.
Mm.
Yeah.
Interesting. This is interesting work.
Oh yeah, thank you.
Yeah.
thank you.
So what do you teach at SIT?
No, we are from the admin, but we
Okay.
look after the lifelong learning.
Oh.
So we are the equivalent of SUTD Academy,
Yes.
which is
I see.
quite new in that sense.
Yeah.
Yeah,
But I think you all have offer a lot more classes.
Yeah, we are more established. I think we are more ahead in this. Yeah. SUTD Academy, different focus. I think you have better research. That's why CET is less. But your faculty don't do CET.
No.
Yeah, you don't do.
Traditionally, a few
Changing lah,
faculty.
changing.
Yeah, so our faculty also don't do.
Push.
Yeah,
They don't lah.
no, our faculty you do more lah, do
Oh,
more. See,
okay.
but they don't do so much research.
Okay.
They do applied research.
I see.
So but we are changing. So faculty are doing a bit more research now. Yeah.
We're
So
trying to
it's almost the same
the
now.
opposite.
Then NUS is also doing CET.
More CET.
Yeah.
Yeah. So they're encouraging us to propose classes.
CET, yeah.
So in your case, the faculty will come up the courses themselves. They will come to you with a proposal.
We are the team that help to scan the market.
Uh.
So whenever there's demand,
we will go to the faculty and curate programs. Yeah. So for example, I lead the business development team, so we will have market sensing, so customers will come to us, say they need a certain need, then I will go to the faculties like yourself.
How do you how do you identify which faculty?
Well, we will know based on the area of research and the area of expertise. Then we will ask them if they are keen to run. And sometimes they will step forward, sometimes they will ask their friends, which are practitioners in the industry, and together we curate.
So do you separately pay the faculty?
Yes, we do. We do. Yeah, I mean,
percentage of your in-house faculty doing CUTD programs?
more than half. Yeah, quite a lot. So SIT has more. Yeah, we are into it. Much ahead. I think SUTD faculty less, much less.
Much less.
Mm.
I have to go and check out
Yeah.
the website.
Yes.
But increasingly a lot.
Mm.
So we try to bring in market experts to partner with our faculty. Because the
Do
faculty.
you do the carry?
Do you help the matchmaking?
Do you do the
Sometimes we do.
Oh.
Sometimes they bring their friends because they are
Oh.
already researchers
Yeah.
from somewhere, and then they will bring their friends who are working in the industry. And easier to do, right? Because the practitioners bring along with them the case studies and the ground practice, then the academics are supposed to teach the knowledge and theory. It's a good match. Otherwise, the classes tend to be less applied in nature.
So you think 3D food really got demand?
Got demand, that's why I
Come and listen.
But
So you
which
came for this.
industry partners do you think would be like food industry?
I don't know. SIT has a food tech program. I don't know whether you know. Yeah, ours is not so much. Ours is more into the technology behind food, and recently gone to those meat analogs and all those stuff. Yeah. So we set up a applied research center known as Food Plant, which does all these alternate food.
So there's more research.
Yeah,
also
but
on
less
CUTD
into
lah.
this. Go and see it. But this is definitely interesting.
Yeah, so I think you all partner with Khoo Teck Puat Hospital. Yeah?
Yes. So the dysphagia work is in collaboration with Khoo Teck Puat. So dietitian from there is also assisting with the needs from the healthcare sector. Yeah, I think do we start to push out this in the hospital? There's talks about it. I cannot remember.
Doing test basing.
Yeah, doing that. Yeah. So different market segment will require different needs lah. I would say because like chocolate is more targeting restaurant and those sector, and healthcare maybe the texture only needs to be right. You don't need to less element to take care of in certain market segment.
Thanks for your time.
Thanks for dropping
by.
I think most of the AUs
Okay.